scheme. We have on the left side the OC Fuse Saver, what we have known already. And then we have the OCO type, open type. We have two types of faults, the transient one and the permanent one. We see here the current, we see here the fuse saver. It's an open or close. If you have a normal current, nothing happens. If you have a temporary fault, fuse saver will clear the fault. Close after a certain period of dead time can be set to 10 seconds, whatever it's needed. And then if the fault is gone, maybe the snake, the bird is burned, normal service runs. If the fault is permanent, then we have the same scenario. We have a normal current, we have a fault current, fuse saver will clear the fault, close again, see, there's still a fault, and open again and clear the fault. And goes in lockout, and then someone has to go on site to inspect the line, to repair, to remove the tree, the branch, the snake, or the broken line, or the insulator, whatever what happened. And we can demonstrate it. Thanks to EP Star, we have 3 fuse saver here, in conjunction with RCU. Forget that one from the beginning. We would like to start with the fuse saver. We have 3 devices. This is, we call them a switch unit. It has a communication module here. And there are 3 single-phase devices, but with this communication module, they are communicating with each other, so that there are again operated 3-phase devices, pseudo 3-phase devices. There is a short-range radio communication, so wireless radio communication, and I would like to show what is happening. So what we have here is phase A, phase B, phase C, and we can simulate the transient fault and the permanent fault. Imagine we have a network, everything runs, which is a normal condition. There's power on the line, and we have a transient fault. The transient fault will be cleared immediately. So all fuse savers change the status, going from red, means closed, to green, means open, there's an eye inside the interrupter, and closed after this dead time, what we have seen here. So if nothing happened, the customer is happy. But now imagine we have a permanent fault.
Reclaim time.
Yeah, we're waiting now a certain period of time. We call that one reclaim time. If in that time a new fault will happen, then the fuse saver will go. So the permanent fault is that one here. And the fuse saver will say, okay, here was a fault, I have to act immediately, then I communicate with the other one and say, oh, first one. So now all fuse savers are locked out. Someone with the RCU, you get the information in your SCADA room without the customer will call you. So then there is a fault message indicator. There's also very beauty function. If your light crew goes out and check on in the network which phase was affected, what I'm here, all phases are off. Where was the fault? You have a fault message indicator, you can see it in the night. The fault was here in phase A, in this case phase A. And this is the idea behind. So this helps you a lot to identify and to check the line. So when the people have repaired the line, then you can go and service again. You see here some 2 levers, the green and the red one. The green one is for open, the red one is for green. Is for closing. So you have to press 1. If gang operated, that means all 3 communicate with each other. If you signal, I understand what you're doing. Then they are saying, okay, we have to close, and synchronously they will close after 60 seconds. So this allows the operator to take the hook stick, put it together, go out of a trench, to step back and wait until the device will close the line again, energize the line again. We call that one hit and run. This gives us a safety feature. This allows you to stay back, and then you can see whether your repair work was successful or not. If not, then you have a safe distance, because then you will see the flash again. So this takes now a couple of seconds, and then it will close synchronously the network again. Let's wait some seconds. But this is the idea of that one. How does it look inside? That's the Fuse Saver, does the job. Load is back, customer is happy. No significant interruption of the network compared to the fuse. So what is inside? The heart of the switch device is the interrupter. It's a vacuum interrupter. Then we have some two current transformer inside, protection transformer, and power current transformer. Because the beauty of that device, it's a self-powered device. So you have seen there's no connection, it's only the device. We have no cable, no VTs, nothing. The current which flows through that device gives the energy to operate the device. Therefore we need a power current transformer. There's a capacitor inside, there's a magnetic actuator inside, makes the movement open and close like a magnet to operate. And of course there's a logic, intelligence, electronic unit inside. Because this device stores the events, stores the fault current, all these information are available. What was the load? You have seen the small normal load, then you have seen the fault current, all the things you can download with the software or transfer to the SCADA from the device. So it's much better than some other sectionalizer, for example, or fuses, especially. So, thanks, Tony. You can see that one here. This is not to open and close. With that one, you have another functionality. If you are working on the line and you know this device makes an open, close, open sequence. So if you don't want that one, you can pull that lever. If you define the function, can be configured. This device will open, close, or will be inhibited. So it means it will not operate anymore. You can block the function. Or you can change the protection scheme. You have two curves inside. A, B, fast, slow, fast, normal, something like that. If you want to change the protection scheme, you can do that by this lever. It allows you a bigger flexibility in your network. For example, you have the rainy season, you want to make it faster than in the dry season, then just pull the lever. You should do it with all three, of course. And to avoid misunderstanding between the devices. And then the protection schemes. No need to go and send a new protection settings to the device. You can just do it with a small lever. This gives you much more flexibility. But most of the customers use it as a hotline tag to block the function of the fuse saver. The operation of the fuse saver, not the function. It will always work. Are there any questions so far?